Dear students, so our first module is over. Now let us discuss about the second module. And here we discuss quadratic residues and quadratic non-residues. Quadratic residues, quadratic non-residues and quadratic reciprocity loop. So this chapter is something interesting and heavily depends upon the congruence relations. We already studied about the congruence relations, some of its properties, the Lagrange's theorem, etc. and so on. So, consider a congruence of the form x square congruence to n mod p. Consider a congruence of the form x square congruence to n mod p, where p be an odd prime. P means p be an odd prime, and n is incongruence to 0 mod p. Then this congruence relation x square congruence to n mod p, this congruence form is said to be a quadratic congruence. This congruence is said to be a quadratic congruence. Quadratic, second degree. So, a congruence form x square congruence to n mod p, where p be an odd prime and n is incongruent 0 mod p, then this form is said to be a quadratic congruence. So, we see by the Lagrange's theorem, if f of x be a polynomial of degree n with integer coefficient, then the congruence relation f of x congruence to 0 mod p has at most n solutions. According to that argument, x square congruence to n mod p has at most two solutions. At most two solutions. Let here x and minus x are the solution of this x square congruence to n mod p. Agreed. Then the congruence form x square congruence to n mod p has a solution. If the congruence form x square congruence to n mod p has a solution, then n is said to be quadratic residue mod p. X square congruence to n mod p has a solution, then n is said to be quadratic residues mod p and is written as nrp. Read it as n is quadratic residue mod p. If x square congruence to n mod p has no solution, it has at most two solutions, then if there exists a case x square congruence to n mod p has no solution, then n is said to be quadratic non-residue mod p and is written as n r bar p. Quadratic residues and quadratic non-residues. Okay, then so find the quadratic residues mod 11. What is the quadratic residues mod 11? Consider x square congruence to n mod 11. X square congruence to n mod 11. Here what is n? N equals so here n takes the values. N takes the values 1, 2, 3, etc. to 10. Okay. So when we have 1 square congruence to when x is 1, so 1 square congruence to 1 mod 11. Agreed? 1 minus 1 is 0. 0 is multiple of 11. So 1 square congruence to 1 mod 11. What is 2 square? When x is 2, 2 square congruence to 4 mod 11. Okay. 2 square congruence to 4 mod 11. What is 3 square? 3 square means 9. So 3 square congruence to 9 mod 11. Okay. What is 4 square? 4 square means 16. So it is 4 square congruence to 4 square 16. So 4 square congruence to 5 mod 11. Why? 4 square is 16. 16. If you divide 16 by 11, 5 is the remainder. So 4 square congruence to 5 mod 11. What is 5 square? 5 square means 25. So 5 square is congruence to 3 mod 11. Enough? What is 6 square? 6 square is 36. 36 also congruence to 3 mod 11. Why? 33. 7 square. 7 square means 49. So 7 square is congruent to 5 mod element. 49, 44 plus 9, 44 multiple of 11. 8 square, 64. 64 means, yes, 5, 9. So 8 square is congruent to 9 mod 11. And 9 square, 81. 81 means 4. So it is 4 mod 11. 81, 77 plus 4. 77 is multiple of 11. 10 square, 100 is congruent to 1 mod 11. 99 plus 1. Agree. So consider the solutions. 1 square, so it is n is 1 here, n is 4, n is 9, n is 5, n is 3, again n is 3, 5, 9, 1 and 4. So these are the solutions. So the x square congruent to n mod p has a solution, then n is said to be quadratic residues. So which are the quadratic residues here? nrp is this 1. Now there is 4, there is 3, 5 and 9. 1, 3, 4, 1, 3, 4, 5, 9 are quadratic residues. So the remaining terms nr/p, the quadratic, they are the quadratic non-residues. Which are them? There is no 2, so 2, 3, 4, 5 here, 6, 7, 8 and 10. So these are the quadratic non-residues. nrp is 1, 4, 1, 3, 4, 5, 9 and the quadratic non-residues 6, 2, 6, 7, 8 and 10. Enough. Okay, so this is the quadratic residues and the quadratic non-residues. Now, consider theorem. The theorem says that let P be an order prime. Theorem says that let P be an order prime. Then every reduced residue system mod P contains exactly P minus 1 by 2 quadratic residues and P minus 1 by 2 quadratic non-residues mod P. The quadratic residue belongs to the residue classes containing the numbers. The quadratic residues belongs to the residue class containing the numbers 1 square, 2 square, 3 square, etc. to P minus 1 by 2 whole square. Okay. So there are exactly P minus 1 by 2 quadratic residues and exactly P minus 1 by 2 quadratic non-residues. We have the numbers 1 square, 2 square, 3 square, etc. P minus 1 by 2 whole square are distinct mod P. Why? If x square congruents to y square mod P. If x square congruents to y square mod P, what do you get? We have x square minus y square congruents to 0 mod P. Agreed? Okay. What is x square minus y square? Means it is x plus y into x minus y congruents to 0 mod P. It's congruents to 0 mod P. Enough. But x plus y, x and y, how many x's are there? At most it is P minus 1 by 2. How many y's are there? At most P minus 1 by 2. So it is x plus y less than or equals P minus 1 by 2 plus P minus 1 by 2. Because there are most x less than or equals P minus 1 by 2 and y less than or equals P minus 1 by 2. That means x plus y less than or equals P minus 1. That means x plus y less than or equals P minus 1 means x plus y strictly less than P. X plus y strictly less than P means x plus y is strictly in congruence 0 mod P. So from here, x plus y into x minus y is congruence to 0 mod P. But here we know that x plus y is incongruence to 0 mod P. What's the means? That means x minus y is congruence to 0 mod P. X minus y is congruence to 0 mod P means x congruence to y mod P. X congruence to y mod P means x equals y. Agreed? Again, so these 1 square, 2 square, 3 square, etc. P minus 1 by 2 whole square are distinct mod P. All of these numbers 1 square, 3 square, 3 square, etc. P minus 1 by 2 whole square are distinct mod P. Now consider P minus k whole square. What is P minus k whole square? P minus k whole square is P square minus 2kp plus k square. Agreed. P square is a multiple of p. 2kp is also a multiple of p. That means p minus k whole square congruence to k square mod p. Agreed? P minus k whole square congruence to k square mod p. That means every quadratic residue is congruent to mod p to exactly one of the numbers 1 square, 2 square, 3 square, etc. p minus 1 by 2 whole square. That is what we reduce here. Agreed? So for any prime p, then every reduced residue system mod p contains exactly p minus 1 by 2 quadratic residues and exactly p minus 1 by 2 quadratic non-residues mod p. Enough? Okay. Now, find the quadratic residues and the quadratic non-residues, NRP and NR bar P of when P equals 3. When P equals 3. What are NRP? Quadratic residues mod P. NRP. P equals 3 means consider the congruence relation x square congruence to 1 mod 3. Instead of B, here it is 3. So, consider the terms, consider the numbers 1 and 2. So, from there, 1 square, what is 1 square? 1 square congruence to 1 mod 3. Sure? Okay. 2 square, what is 2 square? 2 square means 4. 4 means 1 in case of modulus 3. So, 2 square means 2 square congruence to 1 mod 3. So, 1 is a quadratic residues 1 when P equals 3, quadratic residues 1 and the quadratic non-residues 2. Okay. Consider another order prime when P equals 5, x square congruence to 1 mod x square congruence to n, not 1, x square congruence to n mod 5. When P equals 3, consider x square congruence to n mod 5. So here n takes the values. N is 1, 2, 3 and 4. Okay. So again from here 1 square congruence to 1 mod 5. 2 square means 4. 2 square congruence to 4 mod 5. Agreed? 3 square means 9. 9 again congruence to 4 mod 5. 4 square, 16. 16 congruence to 1 mod 5 by 16. 15 plus 1. 15 is a multiple of 5. And yes, 1, 2, 3 and 4. So which are the quadratic residues? 1 and 4. So NRP, when P equals 5, so NRP is 1 and 4. So what is NR bar P? No quadratic non-residues, the remaining numbers 2 and 3. Similarly, if when P equals 7, when P equals 11, when P equals 13, etc. and so on, you can find out what are NRP and NR bar P. When n equals 11, you also see that 1, 3, 4, 5 and in previous example we also see that 1, 4, 3, 5 and 9 are quadratic residues and the remains 2, 6, 7, 8 and 10 are quadratic non-residues mod 11. Agreed? So, this is the method to find out the quadratic residues and quadratic non-residues of mod P. Now let us discuss an important term which is known as Legendre's symbol. So the term is referred as Legendre's symbol. Listen, it is Legendre's symbol. So here let us discuss about the Legendre's symbol and its properties. What is the Legendre's symbol? Legendre's symbol means when P is an odd prime. P is an odd prime means excluding the prime 2 itself. So P is an odd prime and if n incongruence to 0 mod P. Listen, if P is an odd prime and if n incongruence to 0 mod P, then the Legendre's symbol is denoted by this way. Read it as n by P. Legendre's symbol is n by P and is defined as n by P equals 1 if n R P, means if n is quadratic residue mod P, and minus 1 if n is quadratic non-residue, means n R bar P. So this is legendary symbol. For any order prime p, and if n is in complement 0 mod p, then the legendary symbol is n by p and is defined as n by p is 1 if n are p and minus 1 if n are bar p. So if n congruence to 0 mod p, what happens here? N congruence to 0 mod p means p divides n. N incongruence to 0 mod p means p does not divide n. So when p divides n, then n by p is defined as 0. If n is congruence to 0 mod p, that means if p divides n, then n by p is defined as 0. So this is the legendary symbol. Agree. Now, consider if n by p equals m by p, so there is a result. N by p equals n by p only if m congruence to n mod p. So this is an important result. For any m and n, if n by p equals m by p, if m congruence to n mod p. How? So n by p means n by p is either 1 or minus 1. So case first. If n by p is 1, n by p is 1. N by p is 1 means, that means n is incongruence 0 mod p. N is incongruence 0 mod p. N by p is 1. So for n is incongruence to 0 mod p. N by p equals 1 means, actually what is n by p equals 1? N by p equals 1 means n is quadratic residues mod p. That is NRP. Quadratic residues mod p. N quadratic residues mod p means the congruence form. X square congruence n mod p has a solution. Great. X square congruence to n mod p. If m congruence to, but it is given m congruence to n mod p. So listen, x square congruence to n mod p, m congruence to n mod p means, that means n congruence to m mod p. Why? Because of the symmetry. Okay, congruence relation is symmetric. So x square congruence to n mod p and n congruence to n mod p, that means x square congruence to m mod p. X square congruence to m mod p has a solution, that means m by p equals 1. Okay, it is quadratic residues, so m by p equals 1. X square congruence to m mod p has a solution, means it is mrp. So it is mrp, that is, it has a solution, means m by p equals 1. So when n by p equals 1, then n by p equals m by p if m congruence to m mod p. What is the second case? Case 2. If n by p is minus 1, what happens? N by p is minus 1 means n is quadratic non-residue mod p, n r bar p. So that means n r bar p means n r bar p, what is n? But m is congruence to n mod p, so this should implies m r bar p. So why? Because m congruence to n mod p as well as n congruence to m mod p. So m r bar p means, what is m r bar p? M by p is minus 1. So in either case, when n by p is 1 or n by p is minus 1, then m by p equals n by p if n congruence to m mod p. So that is an important result. So for any order prime p, then m by p equals n by p only if m congruence to n mod p. N by p equals m mod p only if n congruence to m mod p. That is true for every odd prime p. Enough. So that's an important result regarding the legendary symbol. So, but by Fermat theorem, what is by Fermat theorem? Fermat theorem states that n power p minus 1 congruence to 1 mod p. N power, since p be an order prime, n power p minus 1 congruence to 1 mod p when if p does not divide a. P does not divide a. So n power p minus 1 congruence to 1 mod p means n power p minus 1 congruence to 0 mod p. Sure? Okay. That means if p does not divide n power p minus 1 means n power p minus 1 by 2 minus 1 into n power p minus 1 by 2 plus 1 mod p. Sure? Sorry, plus 1 congruence to 0 mod p. Enough? Okay. plus 1 congruence to 0 mod p. X square minus 1, x square minus s square, x plus y into x minus y. So it is n power p minus 1 by 2 minus 1 into n power p minus 1 by 2 plus 1 congruence to 0 mod p. That means either it is either n power p minus 1 by 2 minus 1 is congruence to 0 mod p, or n power p minus 1 by 2 plus 1 is congruence to 0 mod p. Agreed? So that means n power p minus 1 by 2 is congruence to 1 mod p, or it is congruence to minus 1 mod p from these two. So that means n power p minus 1 by 2 congruence to plus or minus 1 mod p. So this is an important result. That is obtained from where? That is from Fermat's theorem. When p does not divide Cn, n power p minus 1 congruence to 1 mod p. Okay, so from there we say that n power p minus 1 by 2 congruence to plus or minus 1 mod p. So for any odd prime p, then the result is important. For any odd prime p, n power p minus 1 by 2 congruence to plus or minus n power p minus 1 by 2 congruence to plus or minus 1 mod p. So this is an important result regarding the legendary symbol. Agreed? Okay, thank you.